BKW Physics. I'm Mr. McConley. And we just came back from a long break and we're a little tired, but we're going to get going here. And it's a perfect topic. We're going to talk about power. We're going to talk about power. Now, maybe it's just a guy thing, but when I go to buy a new tool at like Home Depot or the hardware store, and there's two choices. Like say you have a 12-volt cordless drill and an 18-volt cordless drill. I always go with the one that has more power. If I go to buy a car, and I do factor in the gas mileage here, of course, because you want good gas mileage, but if there's two vehicles and the gas mileage is really close, but one has a lot more horsepower than the other, I tend to lean towards the one with more horsepower. Because, to me, having more power makes me feel good because I can get the job done quicker. So what's power all about? I'm hinting at what it's all about. Well, power is doing the same amount of work in less time. Doing the same work in less time. Or you can say the rate at which you do work. The rate at which you do work. You could also say it's the rate at which energy is transferred. The rate at which energy is transferred. So you're either transferring energy or you're doing work, but you're getting it done quickly. That's the key with power. If you have more power, you get the work done quicker. So it's a very simple equation because you just take and you divide the work divided by the time. Okay, so we got W being work, T, lowercase, always indicates time, and P is the new one, which means power. Now, just as a quick review of the units, what were the units for work? Joules of work, J. Time is in seconds. So therefore, okay, power is in joules per second. But nobody cool says that. Everybody that knows anything about power in physics doesn't say joules per second, although it's correct. It's not what we use. We substitute that with watts. Watts, which is abbreviated with a W. So, when you're talking about power in physics, you say how many watts of power. And where we're going with this eventually, not in this chapter, but eventually we'll talk about things like light bulbs. And light bulbs, you'll notice when you buy light bulbs, they're usually rated how many watts. You'll say 60 watts or 13 watts. And the watts is the usage of power. So if the watt number is lower, it uses less electricity, you pay less to use that light bulb. Did you kind of understand that? Now, you can take this equation a little bit further though. Let me just rewrite it. Power is work over time. But we recall from our previous lesson about work that work was force times distance. So we can actually make this equation, power is force times distance over time. That's fine. But let me just highlight that with some parentheses. What was distance over time? First equation of the year, it meant velocity. So actually what we could say is power is force times velocity, which I believe in your reference table is written as a separate equation. So the power is the force applied times the velocity, or it can be the work over time. So let's go and look at the units real quickly for this. Velocity is meters per second. Force is newtons. But all that scrambled together still can give you watts. Okay? Because remember, a newton is kilogram meter per second squared. So by the time it all works out in the wash, power is watts. One more thing before we close this up, very simple lesson today, but one more thing. A lot of times when you're talking about watts, you're dealing with huge number of watts. Like the amount of watts that your house, your home uses on your electric meter that the electric company charges you for. Now if you just did that in watts, the number would be really big. So a lot of times when we're talking about large number of watts, we will use kilowatts. And that kilo meant what? 1,000. So it means that you can take all your numbers and move the decimal place over 3 places when you're talking about kilowatts. Now the way it's abbreviated, just like we learned in the beginning of the year, is a small k, large W. So when you see that, you know you're just talking, the actual number is 3 decimal places larger, kilowatts. So for today, that's it for physics.